So for the past 2 months, a model called Owl Alpha has been quietly sitting at the top of the OpenRouter developer leaderboard. No company name attached, no press release, no benchmark announcement, just a model that developers started using because it was good at coding tasks, and kept using because it stayed good. It handled 10.1 trillion tokens a month, 559 billion tokens a day. It ranked first on the Hermes agent workspace, second on Claude code deployments, third across OpenClaw by call volume, and nobody knew who made it. On June 30th, Meituan revealed that Owl Alpha was Longcat 2.0, and the reveal changed the story entirely. Not because of the benchmark numbers, because of what was underneath them. Meituan is China's dominant food delivery and local services platform. Outside China, most people in the tech industry have filed it under Asian Super App and moved on. Inside China, it has 700 million registered users, processes more daily transactions than any Western delivery platform, and as of late 2025, had committed billions to an AI research pivot that almost nobody in the West was tracking. Longcat Flash, a 560 billion parameter model, came out quietly in late 2025. Longcat Flash thinking followed, and then, without a launch event, or a press tour, or a single coordinated media briefing, the company deployed Longcat 2.0 anonymously on OpenRouter to see if it could survive contact with real developers without the benefit of a brand. It did, for 2 months, and then Meituan told the world what it had actually built. Here is what Longcat 2.0 actually is. It is a 1.6 trillion parameter mixture of experts model, which means most of those parameters are dormant at any given moment. The model activates an average of 48 billion parameters per token, with the active count swinging between 33 billion and 56 billion depending on how complex the query is. This is the same architectural trick that makes DeepSeek models so efficient. A huge total parameter count for knowledge and capability, but only a fraction of that compute engaged on any single request. The context window is 1 million tokens, roughly 750 pages of text, enabled by a custom attention mechanism Meituan calls Longcat Sparse Attention, which keeps the computational cost of long context processing linear rather than quadratic. The model was trained on more than 35 trillion tokens. It was built specifically for agentic coding, not single-turn code generation, but multi-step software engineering workflows where the model calls tools, checks its own work, corrects mistakes, and executes across a long horizon. And it was built without a single NVIDIA GPU. That last sentence is the one that matters most for how this story gets remembered. Longcat 2.0 was trained and served end-to-end on a cluster of more than 50,000 domestic Chinese ASICs. Not NVIDIA H100s, not H200s, not Blackwell chips. Chinese-made application-specific integrated circuits, arranged in superpods with high-bandwidth interconnects, running a 6-dimensional parallelism scheme that Meituan's engineering team had to design from scratch because no existing framework handled the combination of hardware and architecture they were working with. Every communication fault, every memory pressure issue, every numerical stability problem, across a 35 trillion token training run, had to be solved in-house, on chips that the global AI industry has largely treated as inferior alternatives to the NVIDIA stack. DeepSeek, the other Chinese lab that has shaken the AI industry repeatedly, uses domestic chips for inference only. The pre-training, the part that requires the most sustained compute at the highest precision, still runs on NVIDIA hardware in DeepSeek's architecture. Longcat 2.0 is the first trillion parameter model in the world to complete both pre-training and inference entirely on domestic Chinese silicon. That distinction is not a marketing detail. It is the answer to a question that US export controls were designed to prevent China from answering. Can Chinese labs build frontier-scale AI without access to the most advanced Western chips? On the benchmark numbers, the picture is more complicated. Meituan says Longcat 2.0 scores 59.5 on SWE Bench Pro, edging out GPT 5.5's 58.6 by less than 1 point. It scores 70.8 on Terminal Bench 2.1 and 77.3 on SWE Bench Multilingual. Every one of those numbers is self-reported. Independent verification has not yet happened. The model weights are listed as coming soon on Hugging Face and GitHub, meaning the external research community cannot yet reproduce the results. The honest read on the benchmarks is what Fellow AI's review called it: competitive rather than clearly superior. Treat the numbers as a signal, not a verdict. What cannot be explained away by benchmark skepticism is the open router data. For 2 months, Owl Alpha ranked at or near the top of coding agent leaderboards while developers had no idea what they were using. That is not a controlled benchmark. That is production traffic, real code bases, real failures, real developer preferences. The model earned its rank without a name. When the name was revealed, the rank did not change. Now here is where the chip story gets geopolitically uncomfortable. The US export control regime on advanced semiconductors was built on an assumption. The assumption was that China could access chips for inference, but that the most compute-intensive part of the AI development pipeline, large-scale pre-training, would remain out of reach without advanced Western hardware. That assumption is what justified the policy's structure. It is what gave policymakers confidence that export controls could slow China's frontier AI development, even if they could not stop it entirely. Longcat 2.0 does not prove that assumption is completely wrong. Meituan has not disclosed which specific domestic chips it used. Huawei Ascend is the most common candidate in public discussion, but that remains speculation. The hardware gap between domestic Chinese ASICs and the current NVIDIA stack is real and measurable. Meituan's own engineers acknowledge solving significantly harder engineering problems than a lab running on NVIDIA would face. The restrictions still raise costs, slow iteration, and force Chinese firms into difficult trade-offs. But the policy assumption was not that pre-training on domestic chips would be as easy as pre-training on NVIDIA. It was that it would be prohibitively hard. Longcat 2.0 is a company better known for delivering lunch that just ran a 35 trillion token pre-training run on domestic hardware and produced a model that topped developer leaderboards anonymously for 2 months. The geopolitics analysis put the core implication precisely. The binding constraint has shifted. The question used to be whether domestic Chinese hardware could in principle replace imported accelerators. Longcat 2.0 suggests the answer is yes, at least at this scale, at least at this capability level. The MIT license under which Meituan released the model is its own kind of statement. Unlike copyleft licenses that require derivative work to be open-sourced, MIT permits unrestricted modification, commercial deployment, and integration into closed-source products with no disclosure obligations. Enterprise teams can fork Longcat 2.0, optimize it for private databases, and sell the resulting product without telling anyone what it was built on. That is a deliberate choice about how broadly Meituan wants this model to spread, and it is the same license strategy that has made Meta's Llama model so widely adopted globally. Meituan is not just building a capable model, it is building an ecosystem. The flash sale token packs that release 4 times a day at fixed Beijing time slots are a stranger detail. 10 a.m., 4 p.m., 9 p.m., 11 p.m. discounted compute capacity made available in bursts. It is a visible sign that even with 50,000 domestic ASICs, serving a trillion parameter model at global developer scale is a constrained resource problem. The hardware gap has not closed, but the gap between cannot do this and can do this under constraints is the one that just changed. A food delivery company with 700 million users built a frontier-adjacent AI model, trained it secretly, ran it anonymously for 2 months to prove it worked, and then told the world it did not need NVIDIA to do it. The US export control regime was designed to prevent exactly this kind of story from being written. It was written anyway, and the detail that no policy framework accounted for is not the chip architecture or the benchmark score or even the MIT license, it is the source. The assumption embedded in years of US technology policy was that the companies capable of this kind of engineering would be visible, trackable, and known, that policymakers could watch the frontier labs and know where the frontier was. Meituan was none of those things to most Western observers until last week. The next company to do this will probably be equally invisible until the moment it is not. Thanks for watching. This is AI Tides, and I'll see you in the next one.